So in this tutorial we are going to model a geometry as well as simulate it in the motion environment. So let's start with the geometry creation first. For that I'll go to line command. For me it's a shortcut using L. Then this would be a starting point for my link. 100 mm would be my link and 100 mm again would be my second link. Now or I can do one thing, I can remove this other link first, and from this link I'll make the other link also. So select this link in the extrude command and give this vector. This should be a symmetrical value, 20 is fine, and let's give it some offset value as 10. 10 is fine. Press OK. I can also extend it a bit if I want. All is fine now. I can actually decrease the length, so let's keep it 15, and according to that I can make this as 5. So 100 here and 15 in this direction and 5 in this direction, or maybe 5 plus 5 10, doesn't actually matter. Press OK and make a copy in this vector. This is fine. This is a rough idea only. Press OK. Now I'm going to prepare a circle here, which is the location of my revolute joint. So for that, go to modeling, create a point, use this between two points option, click here and here, press OK, make a circle here. Let's suppose 10 mm, 10 is fine. Go to modeling tab again, choose split, select this body and this body. For curves, select this one, make sure this is set as extrude, press OK. Now you can move this into a garbage layer. For my case it is 256, press OK. I'll also move this. Let me check with this one. I think I did not select this body. Okay, okay. So everything has been removed. Switch off this layer, this garbage layer. I'll come to this, and for the aesthetic reasons, I'll create a radius here. 10 would be fine, although it is not necessary, but no problem doing this. Okay, now I'll remove the parameters here, and since we want my link to rotate, I'll move this body in front of each other. Move object, distance is 10. Let me hide this and remove everything and throw whatever I don't want into the garbage layer, which is 256. Press OK. You actually don't have to create all this. I'll provide you the CAD data. This is just for the reference. So I'll change the color of this model. Let's keep it this color, and I can select this body and make it this color. Okay, now we are done with the modeling. We'll now simulate this into the motion simulation environment. For that, go to application, go to motion. We are in the motion simulation environment. Create a new solution. You can name it whatever you want to. Press OK. This is going to be a dynamic simulation. That means I'm considering the mass of these objects, although I'm not going to input anything. This would be done automatically. And when I'm selecting automatic, that means this would be a cold drawn steel. It actually doesn't matter in our case. And this would be off because I did not give any constraint to the assembly of this body. If I would have done that, then I would have achieved the links and joints automatically, but not required now. Untick this, press OK. Now I'll create two links. First link would be this link. This would be a fixed link. So Name this as fixed. Select this body. Mass is automatically taken. Press OK. One more thing. Since this is a fixed link, I'll make this option OK. And this is now my fixed link. Create one more link. This should be a moving link. Select this body and the mass selection would be automatic. Press OK. Now we are going to create two joints. Click on this one. My first joint is a fixed joint. So fixed. This is my link. Origin could be anything and vector is this one. I'll make this as 1.5 so that I can view the icon of the made joint in a bigger size. Press OK and expand this. Create one more joint. That would be my revolute joint. So select this as my link. Origin would be the center because that is the point around which my link is going to rotate about. Click this and the vector would be facing us, that is positive y, and the base link would be this link because this is connected to this base link. Here also the scale would be 1.5. Press OK. I hope I'm not going that fast. You can always pause or go back a few seconds and repeat after me. I'm done with everything. Now I just have to do one more thing. For this moving link, I had to provide a driver. So I have several options to provide a driver here. I'll first start with this polynomial. As you know, polynomial is a set of, not actually a set of, it's actually an equation based on these parameters: displacement, velocity, acceleration, and jerk. For now, I'm keeping everything as 0 and giving the velocity as 10. So my driver would be polynomial and the velocity would be 10 degrees per second. And I'll press OK. I've got a symbol which is anti-clockwise in direction. And now I can create a new solution by right clicking here, new solution. I will rename this solution as polynomial because my driver is polynomial, and this would be my normal run. 30 seconds is fine, and this 30 seconds will have steps of 500. Then press OK. Actually, the direction of gravity doesn't actually matter here, so just press OK. It will do the calculation behind the screen, but you will get a prompt. This won't take much time because the geometry is not very complex. Just close this window, go to Analysis tab, Animation, and if I press this, let's see what happens. This is rotating in the anti-clockwise direction, which is following this arrow here. Now, if you want to delay this animation, you have this option of delay. If you press this, you can study motion of this mechanism and observe a few little other things, which in this case are not many, but as we move forward, we'll use this option. Now close this and create one more solution by making this driver as harmonic. Harmonic means the motion could be based on a sinusoidal curve. You can Google that if you want more information. For that, I am giving the amplitude as 10 randomly. Frequency could be 20 or 30, or let's make it 30. 30 amplitude, 20 degree per second could be the frequency. Phase angle is 180. Displacement I am not putting any. Press OK, and I'll create one more solution. Right click on this, new solution. This would be my normal run only, but the name of my solution would be harmonic because the motion I'm expecting is to be harmonic. Press OK. It will again take a few seconds and we'll wait for the results. Close this window, go to this Analysis tab, Animation, and just press this step forward button and see how it performs. A little slow, I can increase the speed of this. So this is my harmonic motion. If you see here, the motion is actually harmonic. Now you can edit the parameters by going into the driver and play with those parameters and obtain a new solution, right? I'll close this and create a one more solution by making the driver as not function, because function we are going to cover in upcoming classes. For now, just remember that function could be anything related to math, or you can make your own custom function. For now, I'm making this as articulation. Press OK and create a new solution. This would be articulation because we are going to provide the motion to the joint. So this would be articulation. Press OK. Wait for a few seconds. If you get a window prompt, then it could contain the redundant constraint. You can just simply ignore that because we know that NX will remove the constraint automatically, some over constraint things automatically. And when you face this window, just select this driver, give the size as 10. This would have 6000 steps. I can drag the slider here and click on this, and I'm getting this result, right? So this was my other driver, which was articulation. So in this video, we learnt about how to make links, then how to make a joint. In this case, it was a revolute joint here and fixed joint here. Then we created a solution, actually three solutions, which was polynomial, harmonic, and articulation. They are all the drivers that you can play with to achieve the desired result. I hope you like this tutorial. Going upon forward, we are going to do more interesting things. So thank you for watching. Stay tuned.